So today in this video I'm gonna discuss about wave, that what is wave, what is wavelength, what is frequency, and some other aspects relevant to waves. So first question arises that what is wave? So definition wise, wave is a disturbance that travels through a medium and it carries energy from one location to another, from one place to another. So it is a kind of a disturbance that travels in a medium like air, water, glass, and many more. That is something that we call a wave. Like here in this diagram, that we can see a stone is thrown on still water, and after the collision of the stone with the water, a disturbance has been created, and the stillness of water is gone. Don't care about those background music if you get to listen. Just concentrate what am I saying here on the screen. So here you can see the disturbance traveling in this medium in all direction uniformly, because it's water. It's not always the same, but in case of water we can say that it would be the same all around. So these circular and also these circular disturbances traveling are waves, are water waves. So here it is a simple description of a wave. This is a waveform you can see in this diagram, and there are few terms like wavelength, amplitude, direction of propagation, periods, and frequencies that I'll talk about one by one. So first of all, I'll tell you about the wave cycle. So here you can see a wave in the sea level, or a sea. It is a water wave that is in the sea. So this is the sea level, or we can even call it the neutral level. It is the neutral level, and a disturbance is traveling in it. Sometimes we get these mountains and then these valleys, mountains, valleys, and so on. It's propagating in positive x direction, we can even say, if we consider Cartesian coordinates. So it says the wave is propagating, means traveling. Propagation means traveling in positive x direction. So a wave cycle is this, like from this point to this point, we can call it a cycle. Like here you can see that it is approximately a semicircle, and this is the other half. So when you join them together, you get a circle, you get a cycle. So that's what we call one cycle. The number of cycle per unit time is frequency of a wave. The number of cycle per unit time is frequency of a wave. Okay, so frequency of a wave is directly inversely proportional to time. T means time period. It's not an exact time, it is a time period, like 1 second, 1 minute, 1 hour. You settle a time and you see that how many cycles a wave had in that particular time period. So that is frequency. Now wavelength. What is wavelength? The name itself defines that wavelength is the length of a wave, but we just need to know that in what sense. So wavelength in physics is denoted by this weird sign lambda. It's just a notation, nothing else. We need to know that what is lambda. So lambda, before understanding lambda, you must be aware of these few terms. Like this is wave crust. The mountains that you are seeing here are known as wave crusts, and these valleys are known as troughs. So the distance between two consecutive crests or between two consecutive troughs is known as wavelength. The distance between either two consecutive uh, crests or between two consecutive troughs is wavelength lambda. So as it is a length, then we can use many units of length as its units. So its units mostly are small, like nanometer, micrometer, but it can even have centimeter and meter even, and even further units can be used for it. So it is basically length of a wave. If you are interested in its formula, then the basic formula for wavelength is here lambda equals to v by f. V here denotes velocity and f here denotes the frequency. So as this formula suggests that lambda is directly proportional to v and lambda is inversely proportional to frequency. So if you have velocity too much, then the lambda will be high, but if the frequency is high, then lambda will go low. So this is wavelength. Now here you can even see the definitions of medium propagation and even of wave itself. So this definition highlights a thing that a wave is a kind of a disturbance traveling through a medium, and it carries energy from one place to another. So it is an energy carrier. Basically, wave carries energy. So here you can see the amplitude of a wave, the maximum displacement of any point of the wave from its neutral position. So you can see that the sea level is the neutral position for this water wave, and the maximum displacement in this case are these here. These are the maximum displacements. So this maximum displacement is known as the amplitude of the wave. The more the wave will have energy, the more the amplitude you will get. So that is amplitude. So these were a few basic terms or basic concepts relevant to waves that are not too complicated, quite easy, but still they may make you feel uncomfortable while studying some more complicated topics. So I hope that it would be helpful. Thank you.